Assalamualaikum and good morning to Doctor. We are from Section 3, Group 2, and now we are going to present our project report. First, the title is Hierarch Analysis in Construction Site. This is our group members, Muhammad Syamil Haris, Abdul Hai, Muhammad Faris, Rabatul Adawiyah, and myself, Uzma Auni. In the construction industry, safety is one of the most important aspects because construction works involve many hazards and high risk activities. Without proper safety measures, accidents, injuries, and even fatalities can occur. Therefore, occupational safety and health plays an important role in protecting workers and creating a safe working environment. This project used hierarch method to identify hazards, assess risks, and determine appropriate control measures. This study is also focused on a university water pump station and drainage infrastructure project, which includes demolition, deep excavation, and substructure works. Okay, now we move on to the objective of hierarch study. The first objective is to conduct a systematic and detailed identification of both safety and health hazards that may be present at the construction site. The second objective is to assess the level of risk by evaluating the severity of the consequences and the likelihood of the hazard occurring. And our third objective is to recommend appropriate control measures, including engineering and administrative control to reduce workplace injuries, accidents, and occupational illness. With this objective, hierarch study helps to identify hazards, assess risks, and implement effective control measures to create a safer and healthier working environment.
Okay, so the project we visit is the construction of a water pump station located near the junction leading to Taman University Tun Dato' Ismail TDI in front of the Faculty of Electrical and Electronic Engineering along Peserian Tun Gafar Baba, as you can see at the slide right now. The circular rate. The main purpose of this project is to improve the efficiency of water management and the drainage system, helping to reduce water accumulation and improve stormwater discharge in the surrounding area. During our site visit, we observed that the project was being carried out by a small team construction consisting of two workers, one excavator operator, and one site supervisor. Name is Mr. Shamim. According to information provided on the site, the project is scheduled for completion by the end of 2026. Okay, so as you can see as the slide right now, for the works activities on site, during our site visit, the main activity taking place was excavation work, as you can see at the slide, and excavator was being used to prepare the ground for the construction of the water pump station. We also observed that pipes were stored in a designated area, ready for future installation as the project progressed. As you can see, the slide right now has the four pipe. In addition, minor carpentry works were being carried out, mainly involving the preparation and handling of timber materials required for construction. Overall, the project was still in its early construction stage, with the work focusing on ground preparation, material storage, and preliminary construction activities. And as you can see right now, there is our picture with site supervisor Mr. Shahmin. So as you can see, so for now, for the site condition, for our site construction that we have observed, we observe several site conditions that require improvement to ensure a safer and more organized working environment. Firstly, as you can see at the slide, the left one, there were no guardrail or hoardings around the pump station excavation, which increased the risk of workers or visitors falling into the excavation area. And for the right picture, you can see the stockpile of construction materials was not properly arranged, making the site less organized and potentially creating additional hazard. So for now, next we also notice poor housekeeping and welfare condition, with materials and waste not being managed effectively, as you can see at the side right now, the top left one. In addition, there was an insufficient number of warning signs and barricades to clearly identify hazards areas and restrict unauthorized access, as you can see it is right now. So for the another issue, was the presence of exposed steel bars and protruding nails, which could cause cuts or puncture injuries if left unprotected. Lastly, as you can see at the slide right now, the site has inadequate hand washing and clean water facilities. The workers either had to bring their own drinking water or use muddy underground water to wash their hands, which is unhygiene and does not meet good workplace welfare standards lah. So for the overall of this site, this observation indicate that improvement in site safety, housekeeping, and worker welfare are needed to provide a safer construction environment.
Assalamualaikum and good evening. My name is Muhammad Faris Hakim and I will be presenting about the method of risk assessment, specifically the high-rate table used in our project. For this study, we apply the high-rate method, which stands for hazard identification, risk assessment, and risk control. This method is widely used in the construction industry to systematically identify workplace hazard, evaluate the level of risk, and determine appropriate control measure to reduce or eliminate those risks. To identify hazard, we use job hazard analysis or JHA. In this process, every construction industry was broken down into individual tasks. For each task, we identify the possible hazard, assess the associated risk, and propose suitable control measure. The JHA process consists of 6 main steps. First, we select the work activities that required assessment. Second, we identify the hazard associated with each activity. Third, we evaluate each hazard using 2 criteria, likelihood and severity. Likelihood measures the probability of the hazard occurring, while severity measures the seriousness of its consequences if it happened. The risk score was then calculated using the formula risk equal to likelihood multiplied with severity. Based on the calculated score, each hazard will classify into 2 or 3 risk level, which is low risk with score of 1 to 4, medium risk with score of 5 to 12, and high risk with a score 15 to 25. Next, we develop suitable control measure following the hierarchy of risk control to reduce the identified risk. Now, let's look at the hierarchy table. From our assessment, we identify 10 hazards at the construction site. The highest risk was the absence of guardrails or hoarding around the excavation area, which received a risk score of 16, classified as high risk. The recommended control measure is to install rigid guardrail and physical barricade around the excavation to prevent workers or visitors from falling into excavation area. 2 other high-risk hazards were incomplete use of personal protective equipment and temporary electrical wiring, both with a risk of score of 12. For this hazard, we recommend implementing a strict no PPE, no work policy and replacing temporary wiring with permanent wiring or install GFCI and AFCI protection to reduce the risk of electrical fire. Other hazards such as poor stockpile arrangement, slippery ground conditions, and lack of warning sign were classified as medium risk. Although these hazards are less critical, they still require planned control measures to ensure a safe working environment. In conclusion, the high-risk assessment enables us to systematically identify hazards, prioritize the most critical areas, and recommend practical control measures to improve safety and health performance at the construction site.
Moving into the discussion section, our hierarchy analysis identified 3 critical hazards that required immediate attention. First, the most dangerous hazard is the unguarded excavation with a risk score of 16 classified as high. Currently, only warning tape is used, which provide no physical protection. If a worker or student fall into this 2-meter excavation, serious fracture, or even fatalities could occur. Our recommendation is to install rigid guardrails with a top rail at 1 meter, a mid rail, and 100 millimeter to board. This complies with Factory and Machinery Act (BOWEC) regulations. Second, we observed incomplete PPE usage among worker, scoring 12, also high. Some worker were not wearing full protective equipment. This solution is simple and administrative. Implement a strict no PPE, no site work policy with daily inspection by the site supervisor. Third, the temporary electrical wiring present a fire risk, also scoring 12. Our recommendation is to either substitute with permanent hard wiring or install GFCI and AFCI protection at the power source to prevent electrical fires. Now, the key question, is this feasible? The total estimated cost for implementing all these control in between 5,200 and 8,500 ringgit. Breaking it down, guardrails cost around 3,000 to 5,000 ringgit. Also, the PPE for 4 workers cost 800 to 1,200 ringgit. The GFCI devices cost from 600 to 1,000 ringgit, and also warning signs cost from 300 to 500 ringgit, and hand washing station cost from 500 to 800 ringgit. This total is less than 1% of a typical small infrastructure project budget, making it extremely realistic and cost effective when you compare this potential cost of worker compensation, claims, project delays, legal action, or DOSH work stoppage notice. The investment is clearly justified. Thank you so much. This was my part.
So last but not least, in conclusion, the HIREC assessment conducted at the water pump station construction site in University Tun Hussein on Malaysia successfully identified 10 major hazards and health risks associated with construction activities. The risk assessment results showed that the most critical hazards were unguarded excavation works, inadequate implementation of personal protective equipment, and the risk of electrical fire from temporary wiring. Based on the findings, several control measures were recommended, including installing guardrails around excavation areas, enforcing strict PPE compliance, improving electrical safety system, providing proper washing facilities, and installing adequate warning signage in high-risk zones. By implementing these engineering and administrative controls, the identified risk can be reduced from high, medium, or low levels. Therefore, effective hazard management is essential to ensure compliance with occupational safety and health, protect workers from accident and illness, and maintain a safe construction environment for both site personnel and the university community. Thank you.